Scientific notation is a systematic way in which we can take really big numbers and really small numbers and rearrange them into a power of 10. So as you can see, the number here, 8,900, is converted to a much smaller number, 8.9 times 10 to the third. The value of the number has not changed, nor has the size. It's simply been expressed in a different way. In order to take this figure, or work this system, and change it into scientific notation, the first thing that has to be done is to move the decimal point from its original location on the original number to a point at which there is one non-zero to the left of the decimal. So in the number 4,630,000, the original decimal point is over here. The idea is to move it into the only place where there is one non-zero to the left of the digit. So let's pick that one back up and let's move it to a new location right here. In doing so, we had to move the decimal place a number of times. The number of times that you move the decimal point is going to be expressed as a power of 10. So count from the original number how many spots had to be moved. 1, 2, 3, 4, 5, 6 spots to get to 4.6. The last thing you need to check is whether the original number was greater than 1 or less than 1. The number 4,630,000 is definitely greater than 1, so our overall answer is a positive exponent, or 6. If, for example, the number was 0.00463, we would write that to be 4.63 times 10 to the number of places moved, 1, 2, 3. And then we'd look at the fact that 0.00463 is less than 1, so it's a negative third power. The last thing we need to look at is how to actually perform mathematical functions using scientific notation. When you add and subtract, one of the key points to remember is that the exponents have to be the same. When the exponents are the same, simply add or subtract the front numbers and record the times 10 with the exponent. An example will follow on the next page. Multiplication and division is even easier than that. Multiply or divide the first numbers and then add or subtract the exponents. Add for multiplication, subtract for division. To show these examples, we could have the number 1 times 10 to the second plus 3 times 10 to the third. To understand this situation, you have to actually move the decimal point to make them the same exponent. Note here that we have 2 and we have 3. It doesn't matter which one you move, however, one of them needs to change. So instead of having 1 times 10 to the second, we're going to express this as something times 10 to the third. Now the rule is if the exponent goes up, the number must be getting smaller. So it's an inverse. Exponent went from 2 to 3, that's going up, so the 1 needs to go to 0.1. Now we can add these two values up. 3 times 10 to the third plus 0.1 times 10 to the third is 3.1 times 10 to the third power. To show this in a little different light, let's go ahead and pull these out of scientific notation so we can see exactly what they look like. 1 times 10 to the second is 1, 2, or 100. 3 times 10 to the third is 3,000. When we add those two values up, we get 3,100, or 1, 2, 3, 3.1 times 10 to the third power. The last example that we'll show is that of multiplication and or division. If we take those two same numbers, 1 times 10 to the second power, and we multiply it by 3 times 10 to the third. The math is as easy as multiplying these first values together to get 3, and then because we're multiplying, we're going to add the exponents. 2 times 3 is 6. We added them because we're dealing with multiplication. We would subtract if we were dividing the two numbers.